Hello everyone and welcome back to our information retrieval presentations. Today we'll be talking about modeling in information retrieval, specifically focusing on the classic IR model known as the Boolean model. This foundational model in information retrieval helps systems determine whether a document is relevant based on the presence or absence of specific terms. Using Boolean logic, this model evaluates documents based on strict criteria, making it a straightforward yet powerful tool for certain applications. Let's dive deeper into how it operates and understand its practical use. The Boolean IR model utilizes Boolean logic applying operators like AND, OR, and NOT to match documents to user queries. Each document and query is represented in binary form, where terms are marked as present 1 or absent 0. For example, if a document contains the word machine, it receives a 1 for that term. If it doesn't, it gets a 0. This binary representation allows for precise document matching against queries. Boolean operators define how documents are matched and requires all specific terms to be present or requires at least one term to be present, not includes the documents that contain a specific term. For instance, the query machine and learning will only retrieve documents that include both words. Third step is matching the process. The system evaluates the query against each document using the Boolean operations. Documents that satisfy the query's criteria are retrieved, while those that don't are excluded. Boolean IR is exact in its matching, meaning a document either fully matches the query or it doesn't. Here we will see the formal characterization of the Boolean model. Terms is denoted as Q. It is the user information which is the need, which is known as the query. Document representation is noted as DJ. Index term weight for document wi, j, where each is an element of 0 or 1, where I is the keyword, t is the total words, and j is the document. Query is expressed in DNF, which is also represented as QDNF, Disjunctive Normal Form. Each part of the query is represented by QCC. Similarity function is given by sim, which is also the short form of similarity. Dj, q is equal to 1 if each QCC is an element of QDNF for each ki, gi, dj is equal to gi QCC. Here we will discuss the steps for solving a Boolean IR model. The first step is known as stemming and stop word removal. Pre-process each document by removing common stop words such as and, the, etc. and apply stemming to reduce words to their root form. Words like running, ran, and runner are reduced to the root form run. The next step is formation of the term document matrix. Create a binary matrix with terms as rows and documents as columns. The matrix indicates the presence 1 or absence 0 of each term in each document. Example, a matrix where the term dog is present in D1, D3, and D5 but absent in D2, D4. There, D1, D3, and D5 will have 1, whereas D2 and D4 will have 0. Check. Step 3. Check if user query is in DNF form. Convert the query to DNF if needed, where it is expressed as a disjunctive of conjunctions. Example, the query A and B or C and D is in DNF form. Step 4. Find the similarity between the query and each document. Use the similarity function to determine if each document matches the query based on the Boolean IR model. Next, we will see an example sum to make us understand how Boolean IR model works better. So here we have 5 documents. The document 1 contains the sentence, big cats are nice and funny. Document 2 contains the sentence, small dogs are better than big dog. Document 3 contains the sentence, small cats are afraid of small dogs. Document 4 contains the sentence, big cats are not afraid of small dogs. Whereas document 5 contains the sentence, funny cats are not afraid of small dogs. It would be better for your understanding if you noted down these sentences for better understanding. After the first step, that is stemming and stop word removal, we get the words big, cat, nice, funny, small, dog, better, afraid, which are a total of 8 words. Next, we form the formation of term X document matrix. As we see, big, the first word big is in sentence 1, 2, 4. So 1, 2, and 4 contains 1, else everything contains 0. Similarly, cat is in sentence 1, 3, 4, and 5. That's why they are marked as 1 and rest are marked as 0. Similarly, we perform all of the for all the words we perform the binary representation with 1 and 0. For nice, which is only present in document 1, that's why it is only marked in document 1 as 1. Similarly, it is done for all the rest of the documents. Step 3, we check if the user query is in DNF form. The query given here is funny and dog. So we need to check where funny and dog is located. As we, from the document matrix, we can see that funny is located in document 1 and 5, while dog is located in document 2, 3, 4, and 5. That's why over here it is located in 1, 2, 3, 4, and 5. But as the Boolean operator is AND, both the terms should be present in the document. Therefore, only D5 is the document in which both the terms are present. Therefore, only D5 gets retrieved. Now, the next query is funny or dog. In this, either funny or dog should be present in the document. As we can see, all of the documents contain either funny or dog or both. Therefore, all of the documents are retrieved. Next, we check the query big and dog and not funny. This also query is in the DNF form. Here we see big is in document 1 and document 4. Dog is in document 2, 3, 4, and 5. And not funny is in 1 and 2. Not funny means the word funny isn't there. So as the operator is and K1 and K6 should be present and K4 should not be present in the document as it is negated. Therefore, document 2 and document 4 are retrieved as they both have big and dog, but funny isn't present in those documents. Therefore, D2 and D4 are retrieved. Now, we will talk, as we have seen the how Boolean IR model works with an example. Now we will talk about some of the advantages and disadvantages of the Boolean model. While the Boolean model is simple and efficient for small collections, it has its strengths and weaknesses. Advantages: simplicity and speed, quick processing, and easy to implement for small documents. Clear outcomes, provides a definitive, relevant, or non relevant outcome. Example: in a small legal document database, using contract and liability can yield precise results without ambiguity. Disadvantages: no ranking. Documents are treated equally, therefore lacking relevant scoring. Rigid matching misses documents that partially match the query terms. Example: a query for artificial intelligence may miss documents with synonyms like AI or related phrases. These limitations highlight why more flexible models are often preferred for larger or more complex data document sets. Finally, I would like to conclude with the Boolean IR model serves as a foundational tool in information retrieval, particularly valued for its simplicity and binary decision making process. However, it is limited by its inability to rank documents and its strict matching requirements. As we move forward towards more complex IR needs, newer models address these gaps, incorporating partial matching and term weighting. That's it for today. Thank you for watching our presentation. If you have any doubts, mention them in the comment section or just ask Supriya ma'am. Like, share, and subscribe.